Hello and welcome to Math Method. Today we're going to do something extraordinary. Gonna write a Tetris game, and I'm gonna have to prepare for this night. So give me a minute here. So this is an honorary episode to MPJ. He loves functional programming, so today, with all this coffee, the fika, we're gonna pull through. We're going to make a Tetris with functional programming. I guess I need some more water.
Square, rectangle, trapezoid, tetrazoid.
Oh, Jesus.
Okay, these old commercials are really blowing me away here. Well, Tetris is one of those games where you have to be born yesterday in order to not have played it. But in case you're watching this in the future, I'm gonna give it a rundown. So you have pieces of different configurations, all of them with 4 blocks in them, and you put them on the ground, and they disappear when one line is filled. Let's just start. We start with an index.html that is almost empty. It just has this Tetris title. It has a canvas with ID Tetris. It has a width of 240 and height of 400. Then we reference Tetris.js in a script tag, and Tetris.js we have here. The first thing we're going to do is access the canvas. So we say const canvas equals document.getElement by ID, and I think it was Tetris, and we need to get the context out because you can't draw on the DOM element. So we say const context equals canvas.get context 2D. And just to make sure this works, we're gonna paint the context. So first we say context.fillStyle equals 000 here, the hex code for black, and then we say context.fillRect 00 top left, and then the full width and height of the canvas, canvas.width and canvas.height, and go back to the browser to check, and we draw it. So this is where our Tetris game is gonna happen. Now we're gonna have a data structure for our pieces here. So first I want to look up what the Tetris pieces are like. Tetris pieces. And we're gonna look at this one. And we can see there's 7 of them. And I'm gonna start with the T here. I'm gonna represent this in a 2-dimensional matrix. So I'm gonna say const matrix equals array. And then we have an array of arrays. And then I'm gonna fill up here with the boxes. So I think this had the first 1, 1, 1. Here we have 0, 1, 1, no 0. And top here 0, 0, 0. So here we have a representation of the T piece. The reason I have an extra row here is because when we rotate it, it's much easier to determine the center of the piece. If we only had 2 rows like this, the rotation would be a little bit weird. It wouldn't rotate around the center really, it would just flip up and down. And now I want to draw this first piece. So we say matrix.forEach, and here we're gonna get the row and the Y index. Then we iterate over the row, and here we're gonna get out the value and the X index. In our Tetris game, values of 0 is gonna be nothing, basically transparent or whatever we call it. So the first thing I'm gonna do here is check that the value is not 0. If value is not 0, and then we draw, because if it is 0, we just skip it. So we say here context.fillStyle, And I'm just gonna simply draw red to begin with. And then context.fill rect. And here we can simply say X index for left, Y for top. I'm gonna draw it 1 and 1 in width and height here. So we're gonna get a tiny piece in the upper left corner, I think. Oh no. Need to close this. The loops. Woo! Okay, I think we have a tiny little bit here. We're gonna zoom in to make sure we do. Yeah, that's our tiny little piece here. So let's make this bigger. And we can utilize a thing built into the canvas. That is the context scale. So right after we got context out, I'm just gonna say context.scale. And I want to scale everything 20 times. So let's make sure we can see something now. Yeah, that's much better. So that's the first piece. Now I want to wrap this matrix drawer in a function. So I'm going to say function draw matrix, and we take the matrix here and we just indent this to make it functionable. And then here, just to make sure this works, we call the draw matrix function with our matrix. So this is just a little bit of cleanup. Let's make sure it works. Okay, good. In this draw matrix function, I want to support an offset. I'm going to add offset here. And then I'm going to use the offset for the top and left here. So I'm going to x plus offset.x. And then the same for y plus offset.y. And this means that I will be able to move the piece later. So let's just start with an offset of 5 for both y and x here. There we go. So now I want to add a little bit of a player structure here. We're going to say const player equals, and it has a position, which is going to be this value here. And then it's going to have a matrix, which is this value here. And now we can call draw matrix with the player values instead. Player.matrix and player.position. Good, it works the same as expected. So up here I want to add a general draw function. So I'm gonna say function draw, and it's simply gonna do the draw matrix of the player right now. We copy this up here, and then we only call draw. And this draw function we're gonna use in our update function, because now I want to draw the game continuously. And we can do that with requestAnimationFrame. So I'm gonna create an update function here, function update. And the first thing it does is it calls draw, and then it calls requestAnimationFrame and supplies itself to there. And we initialize the game here by saying update. So now we're going to continuously draw, and the effect that has is that if we move the player position, it's going to draw it again. But obviously now we're not clearing it, so this looks a bit weird. So in our draw method, we're going to start by clearing the canvas. So I'm just going to copy that first rows up here. So let's make sure this worked. So I draw it again there. So now it moved instead, which is what we want. And now we want to be able to have the piece drop. And we can do that too with requestAnimationFrame here. We will get a time from requestAnimationFrame. I'm going to default this time to 0, because when we call the update initially, we're not calling it with anything. And to show how this looks, I'm going to log this time here. You can see that we get a time in milliseconds that increments. So this is basically the total time since the page was loaded. In order to be able to calculate some time-dependent things, I want to get the difference in time. In order to get that, we need to save the last time we saw. So I'm going to create a new variable here, let last time, and it's going to start at 0. And in here, I'm going to create const delta time, and it's going to be time minus last time. And when we have delta time, we need to update last time. time. So let's log delta time here instead to see what that looks like. Now basically we get a time diff here, an incremental time. And that is better for our purpose. So now I want to add two more variables here. One that we call the drop counter, and it's going to be 0. And one that I call the drop interval, and that's going to be 1000. So this number 1000 here is milliseconds. So every 1 second we want to drop the piece one step. So instead of logging this here, we can say drop counter plus equals delta time. And if drop counter is more than drop interval, then we say player.position.y++. And then we reset the drop counter to 0 so that it starts counting from the beginning. So if I did my calculations correct, now we should have a piece that drops every second. Let's see here. Doop, 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 doop. Okay, this is good. The next thing I want to add is some keyboard controls. I'm gonna put that down here for now. I'm simply gonna say document.add event listener keydown, and then we get the event out here, and we can look at the event. The event. So this piece of code is triggered every time I push the keyboard. So if I press left here, I get a keyboard event, and in the keyboard event we have a bunch of data. Most interesting is the key code with 37. This is the nicest way to know what key I pressed, I think. I also see that we have arrow left here and key and stuff like that, but I'm not as experienced with them, so I'm going to use the key codes instead. So that means we can say in here, if event.keycode equals 37, we just say player.position.x minus minus, move player to the left. And we check that it works. Yeah, that works. So let's do the same for the right. And in order to help us with the key codes, I'm going to open a little helper app here that is called key code. And all it does is show you the number of the key you type. I'm going to strike right here and I get the number 39. Whoops. And I copy this, boink, and I paste it in the code. So else if event.keycode equals 39, we move the player to the right. Let's try this out. We can move to the left and we can move to the right. Great stuff. And now I want to add support for down key. And the down key is supposed to drop the piece one step. So let's find the number for down, press down, and I see it's 40. Back to the code, and we can say else if event.keycode equals 40. And I simply say player.position again, but y++. And in then I want to reset the drop counter to 0. Because if we press down, we don't want another drop to happen immediately after. We want that extra delay of a second. Let's make sure we got what we wanted. So drop and a manual drop. You can see that it goes back to the interval. And even if I do this, there's always 1 second delay until the next automatic drop. But now we drop at 2 places. So I want to consolidate this. I'm going to create a new function that is called player drop. And I'm going to implement it up here. Function player drop. And it does the same thing. We can just copy that in here. And then instead of doing this here, we can simply call player drop here in the code. So we should have the same behavior now, but consolidated to one function. Okay, automatic drop works and manual drop works. Good. Now I'm going to add the matrix where we save all the stuck pieces. So in order to facilitate this, I'm going to create a function up here that I call createMatrix. Function create matrix, and it's gonna take a width and a height property. And in here we simply say const matrix empty array, and then we can loop here. So while we have height, so basically we say while age is not 0, we decrease age with 1, and then we do matrix.push a new array of length width, and we fill it with zeros. Then return the matrix down here. So now down here by the player, I'm gonna say const arena equals create matrix, and it's supposed to be 12 by 20. 20 units high and 12 numbers wide. Let's see what this looks like. You can log it out with console.log arena, and we can also say console.table arena. So here we have the log is an array of arrays, and all of them contain zeros. Shouldn't be a surprise, but quite nice. And the console.table shows an array in a table like this. So here's all our zeros, and this is basically where pieces end up when they get stuck. And now we can delete this again here. Instead I want to add a merge function. So we say function merge arena and player. This function is going to copy all the values from the player into the arena at correct position. So we say player.matrix.forEach, and we get the row and the y-index out. We scroll down a little bit. And then we want to iterate over the row. So we say row.forEach, and here we will get the value again and the x-index. Once again, values that are 0 are ignored. So we say if value is not 0, then we do what we want, and we want to copy the value into the arena at correct offset. Say arena y plus player.position.y and x plus player.position.x equals value. We close it here. So I'm gonna show you what merge does. So we can go out here, click this, and now if I run merge arena and player, boom, and then a console.table, the arena, we should see a T here. Yeah, so it copied the ones from our piece into the arena table here. And now we want to have a collision detection function, and we can implement it up here in alphabetical order. So we simply say function collides, or we call it just collide, arena and a player. First I'm gonna break out the player matrix and the player position. So I say const, then I use this tuple assigner, M and O, and it should take the player.matrix and the player.position. Then down here I'm gonna make a for loop for let y equals 0. Y is less the matrix.length. We say plus plus y. Then we make an inner loop here that loops over x. Let x equals 0, while x is less than m of index y dot length. Then we say plus plus x. So now we are basically iterating over the player here. The first thing we check on the player is if the matrix of the players y row and x column is not 0. And we need to check if the arena is not 0. So we say arena y plus offset dot y. So this makes sure that the arena row exists. And When we know it exists, we can access its child. There is a x plus offset.x. This should also not be 0. And I think we should wrap this in another parenthesis here to make sure we get what we want. So if these both are true, we know that we collide. So we're going to say return true here. And if no collision was detected here, we return false in the end. We check the player matrix on index y and x. And if it's not 0, we continue. And then we check if the arena has a row down here and has a column. And if it's not, if it has both of them and are not 0, then return true. So in case the row doesn't exist, it means that we also collide. So if we don't even have the row here, that counts as collision as well. So now I want to use the merge and collide function in the player drop. So I go down here, and if we drop and we collide, that means that we are touching the ground or another piece. So we test collide with arena and player. And if we do, we need to move the player back up. Layer.position.y minus minus. And then we merge the arena and the player. And we set the player back to the top. We say player.position.y equals 0. When the piece hits the bottom, it should just start from the beginning again. So let's see here, we go down here, boom, new piece here. And there you saw that it collision detected earlier. So actually now we should have some t's here in the arena table. You can see here's a t, and there's a t, and there's a t. But we can't see them because we don't draw the arena currently. But that's simple enough to fix. So in the draw method, we can simply say draw matrix, and we draw the arena here. And we draw it from x 0 and y 0. Let's see what we got. So let's try this here. Boom, boom, bam, boom. Looks good. This is very Tetris-like so far. See what else we can do. Can we get in here? Oh, nice. But one problem is that you can go out here. This is not supposed to happen. Your piece should be stopped before it reaches the end. We can do this in down here. I'm actually going to consolidate this to a player move function. So I'm going to say player move here. I'm going to supply it with a direction. So I'm going to say -1. Let's copy this out. And we do the same thing with the right. Player move +1. Remove this. Then we implement player move up here. Function player move. And we take a direction. So instead here we simply say player.position.x plus direction. And if we have moved and we collide in the arena, then we can simply move back. So we can just call player.position.x with minus direction. Minus equals direction. And this needs to say plus equals direction. Now we should not be able to exit the arena here. And we can't exit to the left, and we can't exit to the right. And it should also take into consideration other pieces. Because we have a very stupid collide function. It simply checks if we collide or not, and inhibits it. So I think it's quite stupid, but also quite elegant. So what we're missing now is rotation. To rotate the matrix, we need to do 2 steps. First, we transpose it, which means convert all rows into columns. After that, we can simply reverse each row to get a rotated matrix. Let's create the rotation function down here. Function rotate, and it takes a matrix and a direction. So first we need to say for let y equals 0, and then while y is less than matrix.length plus y. and then the inner loop for let x equals 0 while x is less than y plus x. And then we're gonna do a tuple switch here. So let me demonstrate it here. Imagine we have two variables, one a that equals a like this, then let b equals b. And if we want to switch places of those two variables, then normally we would have to say var temp equals a, then we would say a equals b, and then we would say b equals temp. So if we log console.log a and b, they have the opposite values. But we can do this a little bit simpler. We can say ab equals ba. And now we have switched them back, so we get rid of the temp value. So I'm going to use this technique with the matrix here. So we can write matrix x, y, and matrix y and x equals, whoops, that's not the correct bracket, equals matrix y and x and y, I assume here. So here we have a nice tuple switch. And then we want to check the direction. So if direction is positive, we do matrix.for each, for each row and row.reverse. And else we just reverse the matrix. So that's rotating a matrix. And now we want to implement a player rotate. We can do it here. Function player rotate, and it only takes a direction. And here we simply call rotate player.matrix and direction. Then down in our keyboard handler, we want to bind this to Q and W. Let's check which keys they are. Key code Q81 and W87. So I guess we say down here, else if event.keycode equals 81, we want to player rotate -1. And otherwise, if was it 87? Let's double check. Yeah, it was. Then we want to rotate the other direction. Let's see if this works for us. We should now have a rotating piece. Yeah, looks good. But we have one huge flaw here. And it is that we can rotate inside the wall. And that's not really good, is it? So we're gonna fix that. Up to our player rotate function here. And after we rotate, we want to check collision again. But we can't just check it once, because we don't know what direction we need to move. So I'm gonna check collision in a while loop here. So while collide arena and matrix, then we want to do something. And the thing we want to do is to move the piece left and right, basically to see if we have cleared the obstacle. So imagine this, that we're at the wall here and we rotate. Then we can check, move it to the left and check collide again. And in this case, it will be fine. But if it wasn't, and imagine we had a wall here and we did like this, then we would try to move like that. And that would cause a collision, so we would want to move 2 steps to the left. And then we continue like this, basically. Test 1 to the left, test 2 to the right, test 3 to the left, test 4 to the right, and do that until we have cleared the obstacle. So I'm gonna initialize an offset variable up here, let offset, and it's gonna start off at 1. Then if we collide, we're gonna move the player by offset, player.position.x plus equals offset. But if we still collide, we need to have another offset next time. So this starts out by moving to the right. So next time I want to move to the left. So down here I'm gonna say offset equals minus offset plus offset more than 0. Then we return 1, otherwise minus 1. So I think this algorithm would have something that goes up by 1 and negates it. Let's double check this in the browser just for fun. So var offset equals 1. And then we have, what? So if offset more than 0 here. So minus 2, 3, minus 4, 5. Okay, it checks out. Just we need to fix this thing here. And of course we can't do this forever, so we need to bail in case it didn't work. So down here we can say if offset is more than player.matrix, the first row's length. If it is, that means that we basically, okay, we moved so much that it doesn't make sense anymore. So we're gonna rotate back player.matrix minus direction. And we're gonna return. But we also need to reset the offset. So up here I'm gonna save the position. And say player.push.x here. And then we can just write that back on the player. Push. There we go. So let's have a go. See what it does. So I move into the wall. Okay, I already something destroyed a little bit. Let's fix that. Player.matrix, what's wrong here? Oh, this takes the player here. Let's have a go again. There, now we can rotate without bugs, and it jumps nicely out of the wall when we get into it. So that's good. Well, now it's pretty Tetris-like, but it's a little bit boring because all the pieces are the same. So I think it's time to create more pieces. So create a new function up here, and we're gonna say function create piece. And we take a type argument here. And I'm gonna use the same piece as we see here, and I'm gonna use the same labels O, I, S, C, L, J, and T. So I guess we just get started with this. If type equals T. And I guess we can copy the matrix from up here. Whoop. Remove this. And return here. So let's try this for starters. So basically what we want to do is down here is instead just say create piece T. Make sure we didn't break anything. Okay, checks out. So now we can add more pieces here. What else did we have? We have else if type equals O, just the big box. Copy this, and the box is simply 1, 1, and doesn't. This really doesn't really rotate. What else do we have? We have an L. Let's take it from up here. And the L looks something like this. Then we have the J. Just an inverted L, I guess, or horizontally inverted L. What else do we have? We have the I, the big long favorite piece, the one we will always be waiting for. And so this I'm going to put in a 4x4 matrix, because this is also because it makes it much easier to anticipate the rotation. Then we have the S and the C pieces. So we start with S. I'm gonna copy this smaller 3x3 matrix in here. And the S should be something like this, I think. And then finally, I think the C piece. So this should be 7. We have 1, 2, 3, 4, 5, 6, 7. Okay, I think that looks good. Now we want to get a random of these every time. So I'm gonna create a player reset method here. So function player reset. And here we list all available pieces in a string. So we say const pieces equals, what is it? ILJOTSC. And then we say player.matrix equals create piece. And we can say pieces.length times math.random floored. Then we also want to say put the player at the top. And we want to put the player in the middle. So we can say player.position.x equals arena first row's length divided by 2 and floored minus player.matrix first row dot length divided by 2 and floored. So that should be something. And then we need to run this player reset, I guess, in the... What do we have? We have something where we move down and collide. Yeah, player drop. So after the merge, we run player reset instead of this. Let's give it a shot. So we drop, we got a new piece, perfect. Okay, looks kind of good. Whoops. So this is something we should fix now. When we fill up like this, it means that the game is over. And in order to detect this, I think we can do something simple with collide. So I'm thinking if we just reset the player and we collide immediately afterwards, that should mean that the game is over. So I'm gonna say if collide arena and player, then we simply clear the arena. Arena.for each row and row.fill with zeros. So this is just remove everything from the arena. So let's try if this works. This just, we hold down, we should just stack up pieces and then clear. Okay, cool. That seems to work reliably. Now I think it should be nice with some colors here. And the way we can express colors is just, instead of having a 1 here, we can have a 2 and a 3 and then map that to color names. So let's get started with this. O is gonna get the 2, and then the L is gonna get 3, J is gonna get 4, the I is gonna get index 5, S is going to get 6, and Z is going to get 7. And now we need to set up this color map. So I scroll down here, and I'm gonna put it just simply here, it doesn't really matter. Const colors, and 0 is nothing, so we don't need a color here, we're just gonna pad it with null. Then we can just put some arbitrary colors there for now. So we say red, blue, violet, green, purple. What else do we have? Orange and pink. Is this the right amount? 0, 1, 2, 3, 4, 5, 6, 7. Yeah, seems to check out. Then in our draw matrix function, instead of saying context.fillStyle equals red, we can just say colors and the value that we have. So let's see if this does what we want. Okay, red, blue, and this, doink, whoop, 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 whoop. Yeah, seems to be working. Well, the colors aren't really beautiful, so I have prepared a set of colors here that I like better. Let me copy them in here. Whoop, there we go. Ah, it's a true work of wonder, this. Let's play around a little bit. Oh, the Tetris savvy user should notice that we didn't collect the rows. So that's the part that's missing. Let's go and solve this problem now. I'm gonna add a new function and I'm gonna call this arena sweep. Function arena sweep. And in this one I'm gonna have a for loop that says for let y equals arena.length. So we're gonna iterate from the bottom and up in this case. So it's actually arena.length minus 1. Then we'll do this while y is less than 0. And here we're gonna say minus minus y instead of plus plus, as we usually do. On the next row, we're gonna loop over x in the normal direction. So you say for let x equals 0, while x is less than arena of index y dot length, and then plus plus x here. And the thing we do here is we want to check if any of the rows have a 0 in it. If it does, it means that it's not fully populated. So we can say if arena y and x equals 0, means that it is not fully populated, then we can continue. So that means that we just go up here again. Usually continue just continues the current for loop, so in this case this doesn't make sense. But there is a little bit of an obscure trick here in JavaScript. If we set a label here that's outer colon, then we can call continue outer down here. If we do like this, we'll first iterate over the lines, then iterate over x, and as soon as we find a spot in the line that is 0, we just continue on the next row. If we didn't find any spots, we're gonna be down here, and now we can remove that row from arena. So say arena.splice, and index is y, and length of the splice is 1. And then we're gonna do another trick here. We're gonna immediately access, because splice returns all the rows it brought out of the array. And by saying 0 here, we immediately reference the index y of this next row. And we can immediately then fill it with zeros. So if we say const row equals this, we should have an empty row here. And that row we can put on top of the arena by saying arena.unshift row. So this line takes the arena row out at index y. It fills it with zeros. Then we save that row in here. And then later we put it on the top of the arena. Since we removed an index down here, we will have to offset the y, so we simply say plus plus y down here. This arena sweep method we can also run in player drop. Player drop. So after we reset the player, we do an arena sweep. Let's make sure this works. So we don't have to wait for this, we can say arena19.fill with ones. So now when we collide, it should disappear. Didn't work at all. That's so great. Guess we're gonna debug. Populate, and we boom, we get the debugger into arena sweep. That looks fine. The arena length, so here y is undefined, and now y is 19. So that means that, oh, we need to say while y is more than 0 here. It's a little typo, I guess. So let's remove the debugger here, the booger. There we go. So boom, and we take another one for good measure. Let's see them both disappear. Blop, great stuff. When we sweep, we want to count scores. So I'm gonna create a new element here, where we can put score. So I name this with ID score. And then we're gonna add a simple helper function for this down here that's called update score. Function update score. And it's simply gonna say document.getElement by ID score dot inner text equals player dot score. Then of course we need to add a score holder here on the player, score 0. And another thing we should probably do while we're here is just to reset the player initially, because right now we have a little bit of weird default values here. So let's call reset player down here, a player reset. So anyway, I guess we go back out to arena sweep. And first I want to have a row counter. Let row count equals 1. And then when we have swept a row, I want to say player.score plus equals row count times 10. And for every row, I want to double the score you get. So here we simply multiply row count by 2. Row count times equals 2. Then we also need to call update score when we have swept. I think that is in the player drop function. Yeah, so here we update score just for the sake of it. And we should also probably reset the score when we have a disaster. So this is in the player reset, and we immediately collide. We empty the arena, we set player.score to 0, and we update score. Let's see if we have any success with this. Okay, we don't see. Okay, there the score came. So I guess we need to bootstrap the game with update score once at least. Update score. There we go, that looks a little bit better. And now let's see if we get score. So now we should get 10, because we have 2 lines. I mean 1 line. Okay, 10 in score. So let's fill some more lines. Let's take 2. And now we should get 30, because first 10 and then 20 for next row. Yeah, 30. Let's go crazy here. 18, 19, 17, and 16. Now we should get, I don't know even. Wow, 150. So I guess that's 10 plus 20 plus 40. I can't even count this high. But it's a lot of scores, at least. And now I think we have a rather good Tetris here, to be honest. It could probably be a little bit more beautiful, but let's just make sure it works. So boom, there. Want to put that piece there, perfect. Good piece, a blue one, we want that. We want the box, another box. Ooh, boom. Ooh, this is nice. And then let's see what happens if we break it. Boom, we got 0 score and it cleared. Well, that's pretty Tetrisy to me. Let's spend some time to style it up. So we can do that here, and I'm gonna add a style tag, style. And here first I want to say body, and the background should be a little bit darker, so I'm just gonna wing it to 2020-28. So it's a blue hintish dark gray. And the font should just be white, so we can read the score easily. And we of course want a sans serif font family. And we want a little bit bigger font size. They set this to 2 EM, I guess. And then we want to text align everything. Whoops, text anchor, text align center. So this should put everything in the center. Everything went wrong. Classic CSS this. Oh, forgot to close the style. Okay, it's centered and I think the colors are fairly okay. Just one more thing. Yeah, we want to set the canvas to have a border. Border solid 0.2 EM and white. And then we also want to set the height to 90% of the viewport height. So there we go. Looks like we have a Tetris. Yeah. This checks out. It is a Tetris indeed. So that, ladies and gentlemen, is how you create a Tetris.